Hi guys, welcome to our channel, and in this video I'm going to introduce the topic called as trigonometry. So this is an introduction to the subject called as trigonometry. So trigonometry comes from the Greek word trigon, ometria, and then metria. Alright? So this means three, and then gon means side, and then metria means measurement. So when you add them all together, measurement. Alright, so this is the measurement of the parts of a three-sided polygon, or measurement of the parts of a triangle. So we write here measurements related to the parts of a triangle. Alright, so we have so many kinds of triangle, and we'll try to cover all of them later. Alright, so basically we'll feed you with basic information about the triangle. Let's say, for example, I have here a right triangle. Then we know that it has parts. Okay, let's say that it has three angles in it. So this is angle A. Okay, so this is also the vertex. Alright, so this is angle B, and this is angle C. So if it is a right triangle, which means that it must contain at least one right angle. So the largest angle right here facing the hypotenuse is what you call the right angle, and opposite the biggest angle is the hypotenuse. Alright, and here we have two other angles, as you know it. We have angle A and angle B, and we know that the sum of all the interior angles of any triangle, of course, and any triangle is equal to 180 degrees. Alright, so that works not only for a right triangle but in all kinds of triangles. So you can check actually. Alright, so in our case we have angle A, or the measurement of angle A, plus the measure of angle B, plus the measure of angle C. Alright, so let's make it clear. Angle C is equivalent to 180 degrees. Alright, so which means that in our case, since it's a right angle, or right triangle rather, angle A plus angle B, plus we know that angle C is 90 degrees, so I'm not gonna write that, is equivalent to 180 degrees, which means that angle A and angle B are complementary. Okay, so when they add up to becoming 90 degrees, because if you transpose, or to the other side, um, that will become 180 degrees. So we put it on the other side, so yeah, subtract that. So we subtract 90 from both sides of the equation, and it will result to 90. We know that angle A and angle B right now are complementary. So that is if it is a right triangle. So angle A and angle B are complementary. So some other information, or some other functional formula about the triangle is when we try to, let's say, calculate for the perimeter. Alright, so the perimeter of the triangle goes like this. So opposite angle B is side B. Alright, so this is side B for base. Alright, and then opposite side angle A rather, is A, which is my altitude, sometimes called as height. Alright, so um, and the opposite angle C is the hypotenuse. You can um, name it as C or sometimes H. Alright, so H for hypotenuse or C. Okay, so that means you just have to add all of the measurement of the base plus the altitude plus the hypotenuse. So add the sides and then you're gonna get the perimeter. So for the area, um, we use the blue one. So area is equivalent to 1/2 uh, times base times height. So why is it like that? Because if we're going to draw a square rather, or a rectangle, all right, so a square, let's make a square. So the side of the square are all equal to one another. So I'm not that sure if it's yeah, so there it is, little square. All right, so means to say that if we draw cut the square into two, it creates two right triangles, symmetrical. All right, that means whatever is the measure of the other is also the measure of the other one. All right, so we know that the area of the square is actually equal to S times S. Alright, so that's the area of the square, but we need the 1/2 of that. Okay, so this is actually equal to one side of the triangle, which may be A or which may be B, or because in the case of the square, they are equal, so we can change them. So it means to say we need the 1/2, so we write the 1/2 here, and then times the side times side, and this can be since we are speaking of the triangle, talking about the triangle, the parts are base times the altitude, or base times height. All right, so that's why we get this um, formula for the oops, for the area of the triangle. So these are uh, some information about the triangle. So next is, if we want to get the hypotenuse of the triangle, we need to apply the Pythagorean theorem. Alright, so I'm gonna draw another triangle right here. I mean a triangle. A right triangle right here. So again, so this is angle A, angle B, and then this is angle C, and we know that it is a right angle, and here is our hypotenuse. So Pythagoras devised a theorem that tries to prove that the sum of the squares of the legs of the triangle, namely the legs are the base and the height or the altitude. So he says that when you square that, that equals the square of the longest side. Alright, so um, according to his theorem, it is a squared plus b squared is equivalent to c squared. Alright, so if you want to get the hypotenuse, you want to take the square of both sides, so that c squared is equivalent to a squared plus b squared, then take the square. So when you take the square of this, you can find the length of the hypotenuse. So the hypotenuse C is equivalent to the square root of, yeah, a squared plus b squared. So one familiar example is if we let b is equivalent to, okay, b is equivalent to 4, okay, and then a is equivalent to 3. Okay, let's assume that this is 3 and b is 4. So let's apply this formula. C is equivalent to the square root of, oh, that's not the right color that I want to use. Alright, so put that in a parenthesis. Okay, so that's the value of a is 3, so we write 3 here, and then raise that to the power of 2 plus b, which has a value of 4, then raise that to the power of 2, and then um, take then raise that to the power of 2, and then 3 squared is 9 plus 4 squared, which is 16. Okay, and we all know that when we add it together, you're gonna get 25. So square root of 25. Okay, I'm too excited for that. Then that's the value of C, and C here is 5. Alright, so yeah, so C has a length of 5 units. So C here is our hypotenuse, and we can equate that. We can give it a value right now, and that's equal to 5 units. So that's how we apply the Pythagorean theorem in getting the legs of our triangle. So we're going to use the same triangle again to find the other leg. So consider that one leg is missing. So don't want to save it. Alright, so another triangle. Alright, so this is angle A. B, C. So let's say, for example, C is 5, okay, and then one leg is missing. Let's say, for example, we know that this is 4, and pretend that we are looking for A. Okay, A is missing. Okay, so we follow the P theorem or the Pythagorean theorem. Okay, states that the formula is the sum of the legs of the triangle A squared plus B squared is equivalent to C squared. And then this one is missing. Okay, this one is missing, so we have to derive for that, and then we subtract both sides. Why do we have to subtract? Because we need to isolate A, and what's with a is b, and we want to remove it from this part of the equation. We want to transpose that, but transposition is not the right term. um, so we subtract it from both sides of the equation, and to properly do it, it's like a squared. All right, so we subtract b squared from both sides, so we subtract it from here. If you subtract b squared here, you subtract it to the other side. Okay, and do some algebraic steps. That goes to 0. So your new formula is a squared is equivalent to c squared minus d squared. Okay, and then you have to take the square root of that. Okay, and you will see that it will cancel out. So you have a new formula for a, or the leg, or the altitude, is equivalent to um, yeah, square root of c squared. Oh, okay, let's use another color. Minus b squared. And now you can execute it. You write a is equal to the square root of c squared, which is 5. Raise that to the power of 2. Okay, minus 4. Raise that to the power of 2, and you will know that that's gonna be 25 minus 16. Alright, so that's 25 minus 16, and that's 9. So square root of 9 is 3. So you have that. A is equivalent to square root of 9. A is equal to 3. And this right here is the confirmation that the theorem is um, proven. Alright, so you add that, okay? But there are other ways to prove this, and you can do some research on how mathematicians try to prove it. Okay, so aside from measuring the sides and sides of the right triangle, trigonometry is also associated with measuring the angle. Alright, so we have trigonometric functions. Okay, we have 6. Okay, trigonometric functions that helps us to find the angle. Alright, so the trigonometric function relates the angle. So it relates the angles to the measurement of the sides of the triangle. Okay, so we have the sine function. Sine of the angle theta, okay, is the relationship between the opposite side of the angle to the hypotenuse. Alright, so that's the sine. For cosine, cos theta is the relationship between the adjacent side to the hypotenuse. Okay, and then we have tangent theta is the relationship between the opposite side over or to the adjacent side. The challenge here is to know which is the opposite side and which is the adjacent side with respect to the angle. So, to show you that, I need to draw another triangle again. Basically, need to draw it in a large and open space, like just like this. New paint. Okay. So let's say, for example, I'm right here, angle A. All right. So uh, sometimes it's called angle theta. Okay, and then this is your point A or vertex. So opposite, okay, the opposite side of angle theta is the side further or furthest away from it. So this is the side that is opposite angle theta, and this is the farthest side with respect to where you are looking at. So if you're looking that way, so the opposite side is this side. Okay, so you will name it the opposite side. And then the side closer to the angle, okay, this one, side closer to the angle, this one, let's use another color. Yeah, this one. The side opposite, no, adjacent or closest to the angle is what you call the adjacent side. And the one opposite the 90-degree angle or the right angle is always the hypotenuse. Okay, so that's how we identify the side. So if I'm now gonna write um, the trigonometric functions, okay, so if I'm going to write again the three trigonometric functions, sine, cos, and tan, with the proper values, let's use the values that we have a while back. So let's say, for example, this is the hypotenuse. Let's name it h for hypotenuse. That's 5. Okay, for the adjacent angle, um, a, and that's gonna be 4. And then for the opposite side here, o, which is 3. Okay, and we are sure that that's actually a right triangle. And I'm gonna write the trigonometric functions right here. So I'm gonna say um, sine theta. Okay, where's theta? So theta is this one. It's equivalent to, as we mentioned, opposite. So over hypotenuse, and that's equal to the opposite side, which is this one, 3, and then the hypotenuse is this one. So that's gonna be 3 over 5. Okay, so for cosine theta, so that's gonna be the relationship of the adjacent over the hypotenuse. Alright, so this is the adjacent side, and it has a value of 4 over the hypotenuse, which is 5. So I'm gonna write it as 4 all over 5. So for the tangent theta, that's gonna be the relationship of the opposite all over the adjacent. And that's gonna be opposite is 3 and then 4 is the adjacent. So that is how we use it in order to find theta. So to find theta, you have to raise it to -1 or the um, so arc sine or second function if you're gonna press the calculator, and we're gonna show you that. Alright, so same figure. I hope I can draw it just the same. Okay, so we have now, it's green. No, I should not use green. So this is um, theta. Alright, and we have identified that this is the adjacent side. So I'm gonna abbreviate it as ADJ, and then this is the opposite side. So I'm gonna abbreviate it as opposite. Then this is our hypotenuse. Alright, so we have the value as 5, 4, and 3. Alright, so let's say for example we need to know the exact value of the angle. So we write, so let's use black, sine theta, then let's use green, is equivalent to, okay, so opposite, so the opposite is, let's use this one, 3. So this is the opposite side over the hypotenuse, and that's gonna be equal to, oh, is this one, then yep, that's gonna be equal to the opposite side, which is 3, and then the hypotenuse is let's use another color, like so, like this one, 3 over 5. So this is not the value of the angle, this is just the relationship. So to get that, you write, and you theta is equivalent to sine -1 or arc sine 3 all over 5. Alright, so and then you get your calculator. So in the olden days, it's actually they use table to find the value of the angle, but right now we have modern day calculators that help us to find the angle. So for convenience, so we divide 3 all over 5, and then use this one, and then that's it. It's 36.86. Alright, so theta right here. Okay, so theta, we use the green one, has a value of 36.86 degrees. Alright, so that's how we get theta. How about the other angle? Let's say for example I want to know this angle. So let's say for example I name this angle as okay, yeah, I need to know the value of this angle phi. Alright, so we can use the relationship that we have built in a while back, that we know that the sum of the angles of the right triangle is equivalent to 180. So that means if I have angle theta here, okay, plus this angle plus the 90 degrees. Alright, so where's that 90 degree? This one. This angle right here is a 90 degree, and that must be equal to 180 degrees. Alright, so I now know theta, so I know that. So and then I just have to solve for phi. Okay, so solving for phi gives me requires me to isolate it and then transpose or subtract 90 and 36, the sum of 90 and 36 from 180 degrees, and that's gonna be equivalent to 180 minus the sum of 90 plus 36.86, and that's the value of phi. Okay, so you add that to 90 minus 180, so that's 53.13 degrees. Okay, so there we go. We have found all the angles of this triangle with just using the sine function. Okay, how about for the cosine? Will they have the same value for the same angle? So let's find out. Alright, so I think I would have to erase this. No, I think I just have to write another one. Okay, same figure. Alright. Assuming that it is the same triangle, and you have angle theta here, you have angle phi here, and we know that this one is a 90-degree angle, so we put something like that. This is the adjacent side. Okay, just right here, adjacent, and then opposite. And then it has a value of 3 units, and the value is 4 units. So this is your hypotenuse, and it has a value of 5. Now, how about for the cosine? So cosine theta is the relationship between the adjacent side over the hypotenuse. So that's actually equal to this side divided by the hypotenuse. So that's when you substitute it, 4 all over 5. And same is true. Find theta using the inverse of cosine. So cos theta negative 1, or cos to the negative 1, are cos 4 all over 5. Alright, so we go to our calculator and try to figure out what's the value of that. Okay, that's gonna be 4 divided by 5. Okay, and then go here, second function, cos, and that's 36.86, which is equal to the one, or to the value that we have calculated earlier. So 36.86 degrees. Okay, so next thing is the tangent function, or of the angle. So you have to draw it again. Basically, drawing it over and over again helps you to recognize easily which is the adjacent side and which is the opposite side. So if you're looking at angle theta here, the opposite side is right here. So you write it as opposite, and then the closest side to the angle is the adjacent side. Alright. So we know that the value of the adjacent side is 4 units, and this one is 3 units. The hypotenuse is 5 units. Alright, so now we are going to find the function of tangent of the angle theta. So that is the relationship between the uh, opposite side over the adjacent side. Alright, so that's gonna be um, opposite is 3 over 4. And then you find theta by uh, using this function. Alright, and let's use the calculator again to find whether we have the same value. So we have 3 divided by 4, that is 0.75, and then second function of the tangent theta, so that's 36.86. So the three trigonometric functions have yield to the same answer. Alright, so that's 36.86 degrees. So it proves that the trigonometric functions are really helpful in finding the sides and angles of the triangle.